Today's talk is called Modules, Modules, Modules. A fun fact about this talk, I originally had submitted it to the Dinosaur.js conference. It was one of the first ones, and the entire abstract was just the word modules over and over again. They wrote me back and asked me to explain a little bit more. I wish I could tell you that I just sent them back the word modules, but I actually acted in good faith, and that became the new abstract. But, oh, I ran to get the clicker, which then, Oh well, I guess I'm going without the clicker today. So, we're in Canada, and French is an official language here, so thought I'd say bonjour. I grew up in Toronto, know a little bit of French. I throw this in front of a lot of my decks. It's like, this cat, I really like it, and I just kind of like put my back to the audience and just put my hands up and just chill out. And first, this was like one of those speaking exercises that you do to calm yourself, but slowly it actually became like a temperature analysis of the audience, because if y'all laugh, I know this is going to be fun. But if you're quiet, I'm like, this is going to be really painful for me. So thanks for being cool. My name's Myles, and I'm a developer advocate at Google. I work on the Google Cloud Platform team. Focus mostly on Node.js and our products and offerings around it. It's worth mentioning that the opinions expressed in this talk are solely my own. These, not talking about Google's ideas on modules. But before we get started, I don't know how many of you know Brad Farias, who's up on the screen now, that I don't want to say that he's individually responsible for modules, because that would be unfair to the other people who put time in. But straight up, we wouldn't have modules in Node right now if it weren't for Brad. So I wanted to just, Brad will eventually watch this video. Can we all just give a huge round of applause for Brad? Yeah, you should all take a photo of this, tweet at him, say thank you. Brad's awesome, and he's put so much energy and time into this problem. It's amazing. So first off the bat, you can use ES modules in Node.js today. In case you didn't know that, we actually shipped module support in Node 8.5. It's behind a flag, -- experimental modules. We could even do it live right now if we wanted to. We can, I think I have this little ES modules folder here. We can see, here's an index file. If you can't read it, say enhance, imports helper from the helper method, helper method's that, and we can just do I should check the version of Node I'm using, and we could just do node -- experimental modules. Oh my God, it's helping. So we can use modules today. We have it. It isn't set in stone. The implementation still is going to move with time, but if you're interested in getting in on the bleeding edge and finding the edge cases and helping us improve it, it's available today. Some interesting bits about our current implementation that's a little bit different than what you might find in the browser. Files have a .mjs extension. We have support for bare imports. Bare imports is the ability of naming a module that's in your Node modules folder. So when you would do require Lodash or import Lodash from Lodash, the ability to not have to put the full path to the module, we call bare imports. This is a Nodism and not something that exists necessarily in the browser. You can import CommonJS. So you can take any file that's CommonJS and import it, and we'll get a little bit more later into how that's a little bit different. You cannot require ES modules, though. So if you try to require anything that's written in ES modules, everything's going to explode. Thankfully, that's a runtime error, so it should probably never make it to production. But just in case you write code and then just ship it without looking, don't try it. Dynamic import is coming soon. So dynamic import is a feature that is going to be introduced in V8 6.2. So it's something that you have in the browser today. Dynamic import is a function that you give a module URL or path, and it will give you back a promise to return the resolved value of that module. This is the path forward to us having access to ES modules inside of Common. Now, because it's in a promise, that does kind of make things a little bit weird if you want to like import things and then export it, which are one of those patterns we use in Node. But again, that's something we can dig into a little bit later. And I recognize that some of our decisions may have made people grumpy. I won't get into the individual decisions that people have problems with. But let's get in and talk about like why we came to the decisions that we have right now. And keep in mind that a lot of the decisions that we have at the moment are so that we can ship an implementation and test an implementation. And there's still room to improve the user experience of modules. And I think that that goes to say that that's true not just in Node, but in the browser. These are evolving specifications, these are evolving environments. And I think that if the JavaScript ecosystem wants to move forward in a holistic way and not see fracture, there's still a lot of work to be done across our entire ecosystem for that. So let's roll back and see how do we get here. So many of you may not know, but ES4 introduced the concept of packages. And they were not as adorable as the one that's on screen. They were similar to C++ namespaces, and the intent was to create something similar to the Java jar system. But we don't need to dig too far into the implementation because it was ripped out of the standards track, it was booted away, it was never seen again. And after this happened, CommonJS is introduced. Some members of the TC39 contributed to the CommonJS specification, but it was not done in the standards track. It was done as its own thing and primarily intended for server-side JavaScript. Node implemented a variant of CommonJS. It's not 100% to the specification as originally laid out, but it's also, in my opinion, kind of the canonical implementation as far as we're concerned today. We can't forget AMD, the A standing for asynchronous module. I think the D is definition, but I didn't put it on the slide, so I don't remember. AMD was part of require.js, but it was only spec'd really in the implementation of require.js itself. It was more of a convention. We saw require.js and AMD as a pattern that was implemented in a number of frameworks such as Angular implemented similar patterns. It was much more palpable for the browser, where CommonJS would block on loading. AMD allows you to load assets without blocking the thread, which is necessary for an experience where you want to go to a website and scroll before you've loaded your 75 megabytes of JavaScript. And UMD was a thing also. Just quick show of hands, how many people struggled with UMD wrappers so they can ship all the things before? UMD was this really awesome bit of magic that you would just wrap around your code that would allow it to check the environment. It's like, okay, well, if it's common, then export it this way. If it's AMD, then do it this way. If you don't got either, just put it on the global object. So this is something that library developers would use a lot to allow a single thing to be shipped that could run in all different environments and paste over the differences. And we're seeing similar projects right now, like David Dalton's ESM is another kind of approach of kind of thinking about this, a way of shimming your packages or your environment to kind of make this problem disappear. But that kind of misses the point of what ES modules are trying to do, which is standardize this, to make it so that we don't have to run shims that introduce weirdness or introduce differences between environments. So ES modules landed in the ECMA 262 spec in 2015. And we've all seen in the last couple months, they've started to actually be released in the browser. So Chrome shipped them. Someone from the Chrome team, which version of Chrome shipped it out? 60? No? Thought they were here. Okay. Well, it's shipped. You can use them in Chrome. I believe you can use them in Edge. It's available out there now. It took a couple years to get there. But one of the things that happened in the process was that the loader was not specified. And it's implemented by the embedder. And so you may be saying, what is a loader, Myles? You just said this thing, I should know what it is. And the loader is a generic term for a workflow that involves fetching, transforming, and evaluation. And so when you have your resources that are part of your tree, you need to fetch all of the resources. You need to transform the resources as part of that, and then a hook to hook into the evaluation stage, which is implemented by the specification and implemented inside of the VM. So when you write import and you specify essentially your AST of all the stuff that's going to execute, the loading phase is what puts all of that into memory for you before the VM takes over and starts executing your code. And this is where one of the first behavior differences gets introduced and where things start to get weird. So CommonJS has asynchronous load and inline execution. What this means is that every time you call require, immediately when require is called, it loads the next file and it inline executes that file as it goes. So it's just programmatic. It's like, hey, we've done require, now we load that next file, we start executing it, and then we come back to the other file when that is done executing. This is fine on the server, where we don't have to worry about things blocking and we can have things just run. This is not okay on the browser, where you can't have it just block in between loading all the resources over the wire. You don't want to like load for 5 seconds, then execute for half a second, then load for 5 seconds, then execute for half a second. It's beyond non-ergonomic. Node.js doesn't have a load step. CommonJS does not implement a load step. It's not part of the specification. And this is actually how Babel was originally implemented. So Babel's original implementation of import was a loose shim around require. It would transpile into require. They've done work now on making things more asynchronous, but a lot of the legacy code that's been relying on Babel has actually been relying on this synchronous load and inline execution behavior as part of how it works. esmodules specify an asynchronous load and a synchronous execution. It first goes through and builds the entire tree of all the files that need to be executed. It asynchronously loads all of those files. Once all the files are loaded, then it moves into the execution phase. This can actually create inconsistencies. So in the load, it goes and fetches all of the text for all of the module graph. It then resolves the specifiers within source texts. It then moves into a linking phase that puts, once the module graph is in memory, it executes in a pre-order traversal and moves through that graph. It then moves into an execution phase in the VM, which requires that the linking phase is already done, and then it moves through in a post-order traversal. The order traversal is where things can get weird between the environments. It's possible that things would execute in a different order, and they're not interchangeable. It's not acceptable to have different execution order between environments, because that's where, like, that is like straight up releasing Zalgo. If we don't know that in each execution we're going to have the exact same thing happen, if it's possible that if you run something in one environment and in another environment it runs differently, that's a problem. The Node.js, well, CTC at the time, actually voted on whether or not we wanted Node's loader to be asynchronous or synchronous. If we had had a synchronous loader, it actually would have paved over a whole bunch of complexity in our implementation. But it would have potentially introduced a difference in behavior between the loader on Node side and the loader on the browser side, which would just be weird. How do you explain to someone like, oh yeah, if you run this in the browser, then like this, we have examples online, it's just weird. I'm not going to get into it because we could talk about that for 30 minutes. But there's other behavior differences as well, not just in this loading phase. The actual resolution algorithm is different as well. So when you provide a label to import, how it's resolved is different in the browser than in Node. So TC39 leaves it up to the hosting environment to determine resolution. For the web, it had to be URL based. You provide a URL to import, and from that it can do a request over the network and resolve the source text that needs to be executed. Node combines conventions of ecosystems in a little bit of a different way. We have a misspelt bare imports, and bare imports was what I was saying before, of the ability to require or import something, and it knows to resolve the Node modules folder. This is implicit in the NPM workflow and implicit in a lot of the workflow that we have for front-end development as well right now. People are not importing from Node modules / Lodash or Node modules / React. They're just importing from React. This is a Nodism. This is, you don't get in the browser and requires build tools. Node allows you to import JSON and have it return you an object that is usable. This is not something that exists in the browser. Node allows you to drop the file extension and it will resolve the file for you in a smart way. It's a nice little hack that allows you to not think about MJS even if it exists on your file system. But dropping that file extension is a nice ergonomic. All the things we're talking about here are developer experience things that people have become used to. It also allows you to import a directory. So you can import a directory that has an index.js or an index.mjs, and Node just knows what to do. This is like a huge behavior difference. None of those behaviors in the loader semantics exist in the browser. And I'll talk in a little bit about this idea of web native modules, the idea that we don't need to have build steps, that we don't need to have servers, which is a huge boon to new developers. It opens up new models of developing applications. And it's just not compatible with the way our entire ecosystem is written right now because it assumes these semantics for the loader. And if that wasn't enough, the code executes differently too. So they have different goals. And I know you're thinking, well, what's a goal? What's this word, Myles? So in ECMAScript, a goal is a pairing of a top-level grammar and a top-level execution mode. So how many people here have heard of strict mode before? Strict mode is an example of a top-level grammar. It specifies what is able to actually be, what grammars are available inside the language. Right now, there are 4 different types of goals that exist in our ecosystem. You could argue that there's more, but these are the ones we're worried about supporting right now. We have script mode in strict, script sloppy, esmodule, and Node.js. And each of these modes have slightly different combinations of that top-level grammar and the execution. So top-level grammars, strict mode versus sloppy mode. And we're able to denote the difference between those grammars with a pragma. By saying use strict, the VM knows, hey, I'm going to execute this, and it's going to have this particular grammar when it executes. The module goal actually has extra grammar changes that are different. So it's an extension of strict mode, kind of, but not really. But some things that aren't available anymore is HTML comments, which most of you have probably forgotten about. And I've actually done you a huge disservice by reminding you that you can write HTML comments in JavaScript, because guess what? You can't anymore. But you can in Node, but you can't in esmodules. So, await is a reserved keyword. And this divergence of different things is going to change over time. One of the nice things about having a new goal for modules is that it can make a whole bunch of assumptions based on the fact that you're doing modules. And so over time, as more things land in the standard, we're actually going to see a larger divergence from the module goal, from the like strict script mode or even the node goal. What's tricky though is that unlike strict and sloppy mode, which you can use strict to move into that like script strict mode, there's no in-source way of determining if you're in an ES module, aside from actually parsing and seeing that there's imports and exports and certain symbols in there. We had discussed using something like use module as a pragma to be able to denote this at an environment level, but that was considered out of scope of the standard at the TC39, and for good reason. And I'm not going to dig too far into that right now, but grab me later if you want to talk more about why ES module didn't move forward. But simply put, there's still nothing stopping Node from implementing ES module, doing it, and standards work kind of in an inverse way than you would think. The standard ECMA 262 can actually just be thought of as another JavaScript implementation. It's just done using the language of standards. So if a whole bunch of the actual implementations start implementing things, it will find its way into standards. That's how you standardize. So we don't necessarily need to use things like pragma in a standard-driven way. We can actually start by implementing it and then see what happens from there. One thing to keep in mind, though, is there's a whole bunch of other potential future goals, which further complicates this. Binary AST is a really interesting goal that's being talked about right now, where like your entire module could be compiled into a binary AST that could be required by itself. WASM is a goal that a lot of us are really excited about, being able to transpile other languages into Node, into the browser as well. Webpackage is a format that other people are talking about as well now. I don't know as much about it, but there's a whole bunch of GitHub stuff that you can look up for that. And HTML modules are another potential future goal. As each of these come in and we have more and more goals, some of the solutions that we've talked about, like use module, don't necessarily scale if we have to introduce all these different pragmas. Or pragmas don't even work in something like a binary AST, which doesn't have pure script in it at all. So one of the reasons why we may not actually move forward with thinking about pragmas as a way of solving this is it doesn't scale to all the potential future goals that the language may have. But we still have to pay the cow path. We still have to figure out how we reconcile between these environments, and we have to figure out how we empower like the 10 plus years of ecosystem growth that's happened to not just all of a sudden everyone have to redo everything from scratch. And interoperability is one of the main ways in which we've thought about and tried to do this. Interoperability is the ability to use ES modules in Common and use Common modules in ES modules. So right now, if you want to load ESM from Common, import ESM is really the only way it will work. As I was saying, it comes in V8 6.2. We have a pull request against master right now to land that on master. V8 6.1 is going to land into Node V8 in the next week or two. And we're already working to figure out if we can make a compatible version of 6.2 to land into the LTS stream. There's still some discussions that we have to do on an LTS level if it's something that we want to do. But it is possible that dynamic import will land in 8 LTS. You cannot require ESM though. This is due to all sorts of weird timing issues, as we were saying before with the sync load and async load differences between the two different things. If you try to synchronously load an ESM, that doesn't really work from a fundamental level. If you want to load CommonJS from ESM right now, you can simply import from a function. Right now we don't support named imports because of the indeterminism and timing problems that we have with CommonJS. Right now CommonJS only exports defaults. It is possible, because all of the JS of our core modules are all compiled into the source, that we could do some fancy stuff to allow for named exports of our core modules. But generally right now, userland modules will only provide defaults. Now, this could potentially be fixed in a platform level with explicit restrictions. So if we allowed some sort of way of restricting the exports of a CommonJS module to make sure that they're deterministic, we could potentially allow for named exports of CommonJS. But this actually raises a higher level problem. Should we? And I don't think that we've actually come to an agreement there. But if you're able to load CommonJS from ESM, this becomes a Nodism. This becomes something that only is supported in the Node platform. It would never work in the browser without needing a transpiler or some sort of build step. So all of a sudden you have this thing that like works on my machine when you're on the server, but the second you try to take the same code to the client, it just blows up and stops working. So there is pushback saying like maybe actually we just shouldn't support importing CommonJS at all. And if we didn't support importing CommonJS, we actually wouldn't even need the MJS extension because we could just load JS and call the ES modules JS. But it's not actually that simple because then how do we know if it's not common, and it gets weird. But this is the kind of conversation from a user experience level that we need to start to have. And it's very different from the conversations that we've been having in the past, which are primarily just about like how do we even implement this to begin with. More behavior differences. How do we reconcile this? ESM does not have a way right now to inject lexically scoped variables. And whether or not you know it, you use lexically scoped variables in Node all the time. Some examples of these include underscore underscore file name, underscore underscore dir name, require, module. These are all things that are lexically scoped to the module without you having to have them at all. If you try to use ES modules today in Node, you won't have access to any of these. Import.meta is in the standards track right now and could potentially solve this by allowing environments as well as modules to specify metadata that can become lexically scoped inside of the modules when they're required. But it just gets really weird. That's kind of, I guess that's the takeaway from my talk. Things are weird. But like, we're working on this and we're trying to figure out how to pave the way in to allow for stuff like this. Which leads us to, what does the future look like? As I mentioned before, ESM is one of many potential goals. It's really easy to try to solve this problem by thinking of it as a binary. We have Node, we have ESM, all we have to do is solve the inconsistencies between the two and then we're good, but we're not. With all these other goals that are coming in, with all these different ways of running and executing JavaScript, it's not so simple. We need to solve this problem in a way for many. And if we do it in a short-sighted way right now, we're just going to have the same problem in 2 years. One way of potentially solving this is through hooks, which are coming to both Node.js and the web. A resolve hook would allow you to hook into the runtime when you're actually resolving the modules themselves. A resolve hook could be the kind of thing that would allow us to solve problems with the resolution differences between the environments. If web developers or platform developers could specify custom resolution algorithms, this could solve some of the problems that we're having with the inconsistencies with bare imports. Evaluation hooks are really interesting because they potentially allow you to hook in to the runtime and modify the source. This is very similar to what we've seen with ASTs with Babel. The ability to do this in real time could be really powerful. I don't know necessarily that all the environments are thinking about implementing it this way, but I've seen a lot of stuff happening in the JavaScript world around transformation, around AST manipulation, and I think that that's an exciting potential future. Right now, they're not thinking about transform hooks because the majority of things that you would want to do in the transform phase could happen in the evaluate phase, but that's kind of being pedantic. Really, having these hooks at all would be a huge step up from what we have. But hooks are going to de-opt. If you have hooks with like custom ways of doing things, the engines are not going to be able to optimize in the exact same way as they could if you're using the default loader. So I'm imagining the people from the V8 team right now kind of shuddering, thinking about 100 different loaders existing out there in the wild. And that's the kind of thing that could maybe either block things like this from happening at the standards track or halt development if custom loaders make things a lot slower. I've had some interesting thoughts around how we could maybe fix this at the network level or in service workers, but these are all just ideas with no actual code right now. Snapshots are a really interesting thing that we could do as well here. So as I mentioned, after the loading phase and after the linking phase, we have a binary representation of your module in memory. So a hook could allow us to dump that in-memory snapshot, which could in turn allow us to load that in-memory snapshot later. This is different than taking VM snapshots as you would do right now during execution, because you can't necessarily reboot from that snapshot. If you're taking a snapshot during execution, there's all these things that are dynamic that you can't necessarily contain, and again, Zal go everywhere. But if we have everything before execution, we're guaranteed that is deterministic. So if we had guaranteed determinism of the snapshot before the execution phase, this could give us a hook in Node to extremely speed up cold boots in environments like Docker or in Cloud Functions. So this is something I've talked to some people on the V8 team about. I'm really excited about it maybe being something moving forward. And this is a great example of the kind of stuff that Node has to look forward to as we further adopt these new technologies. This isn't something that we ever could have done with Common. MJS is in the IETF standard track, which means it will land in an official MIME registry. MIME types are a way of determining the types of files by file extension. And so one of the things to think about here is that in the browser, anytime you're loading a module, you're doing it by explicitly loading a module. The browser already knows you're loading a browser, and then it loading JavaScript, and it verifies that you're doing it via MIME type, and MIME type is not determined by the file extension there, but it's just determined by the MIME type that's in the header of the packet that's sent back. Node doesn't have that. We have no way of determining what a file type is before we parse or execute it at all. And so one of the advantages to moving in the file extension direction is that we have no ambiguity there. It also scales to multiple types of goals. So if all of a sudden we have WASM and binary AST, we have HTML modules, we have all these different module types, more MIME types scale on both the front and the back end for this. As we find that there's more goals that we're trying to execute, it's no longer this binary problem. I know that the ergonomics of it aren't great, And there's still more conversation to be had around it, but this is a lot of the thought process that's gone into that. .js will always be ambiguous. And on the browser, we can kind of skirt around that, but in Node, we can't. Finding ergonomics that work for all developers is hard. NPM will tell you that 80% of the people installing modules on NPM are using it for front-end development. We can't ignore the ergonomics of the entire stack. I, for one, am like really not a fan of making a divide between browser developers and Node developers, because there aren't. There's just developers. We just want ergonomic workflows that work and don't get in the way. And so there's going to be compromise all over the place to make sure that our workflow is consistent across all the environments we want to run in. But unfortunately, if we make too many sacrifices, we'll lose people, because people want a developer experience that they enjoy. We have to examine this workflow pane, and I think one of the things that we really need to do is maybe step back from first principles and think about what it means to develop JavaScript. We've had this workflow that we've developed using GitHub and Node modules and NPM. That's become a de facto standard right now, and a lot of what we try to do to fix this is extending off of that. And I think that some of the exciting stuff that we're going to see going forward is re-examining that workflow from first principles and rethinking about, hey, we have all these new tools. What are new and interesting things that we can do? But how do we do that without throwing away all the work that we've done? And that, no one really knows the answer to that right now. And that's exciting in a weird way. Like, if everything was solved, it would be really boring. So we all get to work together to try to figure that out. So welcome to the future. And here's a surfing dog. Thank you very much.